So what we're going to go over in day 4, part 1 is 3 variable systems, and we are going to go over solving 3 variable systems. So what you've done before in Algebra 1 as well as in review day 1 in this class, you did solving systems with 2 variables, but now we're going to move on to having 3 variables in a system. And so when you had only 2 variables, you were in 2-dimension. Introducing a 3rd variable in the same equation, so here's an example like this: 2x plus 4y minus 3z equals 5, okay? That is an equation with 3 variables, and this is no longer 2-dimension, this is 3-dimension, okay? So what this would form is not a line, this forms a plane. Okay, think of it as a sheet of paper that extends infinitely in all directions this way. Okay, and if you pause the video and go to the attachment, okay, what I've done is shown all of the different ways that 3 planes, okay, can sit in 3-dimension. Because what we need to do is solve, okay, what we're going to be doing is solving, okay, here's an example of a system. Now, we kind of talked about this in solving 2 variable systems, in which we said 2 variables has to have 2 equations. So if we have a 3 variable system, we must have 3 equations. And what I want you to do, okay, is pause the video and look at the different ways that these 3 can sit in 3-dimension. So you need to be able to see what an intersection looks like, what no solution looks like, and what infinitely many solutions look like. So pause the video, go look at that attachment, and then we're ready to start solving. Okay? Play when you're ready after you've looked at that attachment. Okay, so now that you've looked at that attachment, you've seen the different ways that your system can sit in 3-dimension. So we're going to go through and now start solving the system. So number 1, so we look at number 1, our 3 variables are x, y, z. You do not have to see x, y, z in all 3 equations, okay? But if x, y, z are the variables in your system, you must have 3 equations. So we can see we have 3 equations, okay? Now, in our 2 variable system of equations, our goal was to knock it down to a 1 variable, 1 equation system using substitution and elimination method. Well, that's our end goal to get there, but right now we're at a 3 variable, 3 equation system, and we need to get down to a 1 variable, 1 equation system. What's sitting there in the middle that we need to take care of that's going to get us down to that in order to solve for 1 variable? We first need to get this thing down to a 2 variable, 2 equation system. Okay, so that's our first goal. And we're still going to use substitution and elimination and the rules that we have about being able to multiply by a constant value as well as being allowed to add 2 equations together. So what we're going to do is first label your equations 1, 2, 3. Okay. And what we need to do is get this thing down to a 2 variable, 2 equation system. So how do you get rid of 1 variable? Well, we pick a variable to get rid of. So why don't we get rid of y, okay? And you have to get rid of y twice. And what I mean is, we're going to have 2 equations without y in it. That's going to be our 2 variable, 2 equation system. So what we do is, okay, we have 3 equations. we're going to take two of them and eliminate y in that system. So I'm going to take equation 1 and equation 2, and I'm going to eliminate y. Then we need a different pairing. We can't do 1 and 2 again. So let's do 2 and 3, and I'm going to eliminate y. And then I'm going to be left with two equations without y in it, which means I'm going to be left with two equations with just two variables, x and z. That's what we want. And what we're going to do is use substitution and elimination and adding equations together, which are rules that are allowed and are true. So we're going to take 1, which was 3x minus 2y plus 4z equals 35, and negative 4x plus y minus 5z equals negative 36. Now, keep your work nice and neat. The neater your work, the less chance of making a mistake, okay? A tiny little algebra mistake, or not even an algebra, and seeing that it's negative 36 and accidentally putting 36 here could mess everything up, okay? So just be very meticulous when you do these problems. There's a lot of work that's involved here, okay? So we need to eliminate y in this system, so I'm going to use elimination, and I'm going to multiply. Oh, I forgot the red marker doesn't work. I'm going to multiply this second equation by positive 2, and then I won't have to do anything with the first equation. So I'm going to rewrite the first equation. It's 3x minus 2y plus 4z equals 35. Second equation is negative 8x plus 2y minus 10z equals, now negative 36 times 2, negative 72. And now we have to add those together. So 3x minus 8x, that puts us at negative 5x. Negative 2y plus 2y, those cancel. 4z minus 10z minus 6z. And notice how I put my z. I put a little slash through my z so I don't accidentally think that it's a 2. Okay? Then I have 35 minus 72. That is going to give us negative 37. Okay, and so here's my one equation, right? This we're going to hold on to. That equation right there is two variables, x and z. It doesn't have y in it, okay? And then 2 and 3, so negative 4x plus y minus 5z equals negative 36, 5x minus 3y plus 3z equals 31. And we have to eliminate y again because we want a two-variable, two-equation system. We only want to see x and z, x and z, x and z. So this is a system. We need to eliminate y, so I'm going to multiply the top equation by 3. And that'll eliminate y. So that's going to be negative 12x plus 3y minus 15z equals negative 108. And now we need to add new with the second equation that we have written in this set here. So 5x minus 12x gives us negative 7x. Okay. Your y's are going to cancel there, okay? And then we have 3z minus, that's going to give us negative 12z, sorry, 3z minus 15z, and 31 minus 108 is going to give us negative 77. So here is our second equation that doesn't have y in it. So we're going to take those two equations that have little marks next to them in red, okay? So we just went from 3-variable to 2-variable. Our 2-variable system is negative 5x minus 6z equals negative 37, and negative 7x minus 12z equals negative 77. Now, what you want to do is put this work, don't crowd the work, put this work, okay, write it right below here, okay, have everything flow down, okay, so I'm going to erase this. And so now we have negative 5x minus 6z equals negative 37. Negative 7x minus 12z equals negative 77. Now this is just a two-variable system from Algebra 1. You know how to solve this, okay? So we're going to be able to solve for x and z, and so the last letter we solve for in this system is y, which was the first one we eliminated. So let's see. I'm going to multiply the first equation by negative 2, and then I won't have to touch the second equation here. So I'm going to get 10x plus 12z, okay, equals positive 74. And we're going to add those together. That gives us 3x, z's cancel, equals negative 3. Divide by 3. And I know what x is. X is negative 1. And so now we can solve for z. We can't solve for y yet. We can solve for z because I have two equations, right? I have these two equations right here, and technically I could use this one, that have just x and z in it. So if I substitute this in for x, I can now solve for z. Okay? So this is 5 minus 6z equals negative 37. Take away 5, take away 5. That's negative 6z equals negative 42. Divide by negative 6, and z is 7. Okay? So 2 out of the 3 variables are solved for. To get the third, now we know what x and z is. Where do we have an equation with y in it? The original 3. So pick any of the original 3. I'll just pick the first one. So 3 times negative 1 minus 2y plus 4 times 7 equals 35. So this is negative 3 minus 2y plus 28 equals 35. Negative 3 and 28, 25 minus 2y equals 35. Take away 25 on both sides, that gives us negative 2y equals 10. Divide by negative 2, and we get y equals negative 5. And you give your final answer as an ordered triple. So you do it in alphabetical order. So we're going to write our answer x comma y comma z. So that's going to be negative 1 comma negative 5 comma 7. Okay, so to check your work, you go back, you take x, y, z, you plug it in, you make sure it makes the first equation true, the second equation true, and it makes the third equation true. Okay, so let's move on. Let's do another one. Make sure you keep your work nice and neat. Don't crowd. Just keep going down with the work. And these might take half a page to a full page to do. So, problem number 2. We have 2x plus 4y minus 5z equals 18. Negative 3x plus 5y plus 2z equals negative 27. And negative 5x plus 3y minus z equals negative 17. So here's our system. And so now what we can try and practice with this system here is looking at what's the most efficient letter to eliminate first. So if you look, we have a negative z, okay, and then we have 2z and negative 5z. So for me, okay, I would choose to eliminate z because 2 and 3, okay, they don't share a common multiple. 3 and 5 don't. So it would just be a little less work if you choose to eliminate z first. So that's what I'm going to do. So I'm going to eliminate z. Okay, remember it's the same, it's a 3-variable system is the same process over and over and over again, just like a 2-variable system of equations. Okay, first thing you have to do is knock this down to a 2-variable 2-equation system. How do you do that? Okay, you pair 2 of the equations together and you get rid of one of the letters, and then you pair a second. So I'll do 1 and actually, I'm not going to do 1 and 2. I'm going to try and make this easiest for me. I'm going to do 1 and 3 because I like this negative z. And then I'm going to do 2 and 3 because 2z and negative z, I like that. That's less work. Okay. So 1, but does it matter if you did 1, 2, and 2, 3? No, as long as it's not the same pairing. So 2x plus 4y minus 5z equals 18. And negative 5x plus 3y minus z equals negative 17. And I just need to multiply the bottom equation here by negative 5. And so I'm just going to rewrite the first equation. 2x plus 4y minus 5z equals 18. And then we go through and we multiply by negative 5 every term. That's going to give us 25x minus 15y plus 5z equals negative 17 times negative 5, 85. Okay, we add these together, and that gives us 27x minus 11y, and the z's cancel, equal 18 plus 85. It's going to be 103. So we're going to hold on to this equation. Okay, and so now 2 and 3, so negative 3x plus 5y plus 2z equals negative 27. Negative 5x plus 3y minus z equals negative 17. I'm going to multiply the second equation by 2. That'll get rid of z. Okay. And so I'm going to rewrite the first equation. Negative 3x plus 5y plus 2z equals negative 27. See, my work's getting sloppy already. Then negative 10x plus 6y minus 2z equals negative 34. Add these together. We get negative 13x plus 11y equals negative 27 plus negative 34 puts us at negative 61. Okay, so here's our second equation that doesn't have z in it. So we take those two, okay, put right below your work. Okay, I'm just going to hold on to them because I'm about to erase the board. Right below, rewrite this as a 2-variable system. 27x minus 11y equals 103. Negative 13x plus 11y equals negative 61. Whoop, and I wrote 63. Okay, and so erase. I'm going to erase. Oh, I didn't mean to erase all the way up there. So now I have to rewrite that. Plus 2z. And the third equation was negative 5x plus 3y minus z equals negative 17. Okay. So, sorry about that. So now, we take the 2, okay? This should be right below where you put the asterisk. Okay, 27x minus 11y equals 103. Negative 13x plus 11y equals negative 61. You should be eliminating x first because y already has opposite coefficients. So if we just add these two together, We don't even have to multiply by anything. Okay, we're going to get 14x equals, and then we have 103 minus 61, which puts us at 42. Divide by 14, and x equals 3. And so now we find what y is. So we could do 27 times 3 minus 11y equals 103. Okay, so that gives us 81 minus 11y equals 103. And so now we have to take 103 and subtract 81, and that puts us at 22. And then divide by negative 11, and y equals negative 2. Now, if you get a fraction, okay, don't be nervous, you can get fractional responses here. They don't always have to be integers. And so now we have x, now we have y, okay. We just need z, so we go back to one of the original. So I'll just choose the first one. 2 times 3 plus 4 times negative 2 minus 5z equals 18. So 6 minus 8 minus 5z equals 18. That's negative 2 minus 5z equals 18. Add 2, negative 5z equals 20. Divide by negative 5, z equals negative 4. So our order triple x, y, z would be 3, negative 2, negative 4. Remember, this would be a point in 3 dimension. Okay, so that's number 2. Now I want to show you one before we get into our special cases so that you feel comfortable working on a problem like this on your own. Okay, so here's our 3-variable system. Our variables are x, y, and z. Notice, one of the equations does not have x in it. That is perfectly fine, okay? As long as x, y, and z appear somewhere in these 3 equations, you have a 3-variable system. So, you could even have, this third equation could be missing a z. Okay, you could have yz here, xyz, and xy. That's still a 3-variable equation system that you have going on here. Okay, so you have to look at what you have and try and fit the pieces where they should be. Okay, figure out, it's like a little puzzle of how I can do this, because our goal right now is to get this to a 2-variable, 2-equation system. Okay, now, one of these equations already is missing one of the letters. Okay, the first equation already was without x, right? Equation number 1, x is already missing, right? So 3y minus 5z equals negative 23. So all I need to do is take equation 2 and equation number 3 and eliminate x, and then I have 2 equations without x in it. Okay, so I'm going to take equation 2, 4x plus 2y plus 3z equals 7, and negative 2x minus y minus z equals negative 3. Okay, if you did not want to do that, if you don't like the little change that I made, you can continue. You could pick eliminate y, okay, and then you could just do the pairing 1 and 2, 2 and 3, and get rid of y, and then you would have a system with just x and z in it. That's perfectly fine to do, okay, but this is a little bit of a more efficient way of going through and doing this problem. So I got to eliminate x. Don't have a choice here. Needs to be done. Needs to eliminate x if I'm going to pair with this one. So that means I need to multiply this equation by 2. Okay. So rewrite the first, 4x plus 2y plus 3z equals 7, and negative 4x minus 2y minus 2z equals negative 6. Add them up. X's are gone, and look what happens. The y happens to go away too, and we're left with z equals 1. Perfectly fine. Okay, it is perfectly fine if more than one variable cancel out here, because what that means is I already have the answer to 1, so it's even better when this happens. So here's my two variable, two equation system. This is still, whoop, wrong red marker. This is still a system, a two variable system of equations, those two together, okay? So right below this, okay, this work should be there, z equals 1 and 3y minus 5z equals negative 23, except you already have the variable solved for you. That's pretty good, because it means it's going to be less work. Okay, so yours two variable system without x in it looks like this. And you already know that z equals 1. So now we just have to do 3 times, whoops, 3y minus 5 times 1 equals negative 23. So 3y minus 5 equals negative 23. Add 5, and we get 3y equals, whoops, sorry, add 5. I don't know why I put it 20. Oh, I'm doing that. Negative 23. Add 5, we get negative 18. Divide by 3, and we get negative 6. So, okay, we've got 2 of the 3. Now we just need to find what x is. So we can't plug it into this one. We're not going to get x. Second or third, I'll plug it into the second equation that's there. 4x plus 2 times negative 6 plus 3 times 1 equals 7. 4x minus 12 plus 3 equals 7. 4x minus 9 equals 7. 4x equals 16. X equals 4. So 4 comma negative 6 comma 1. Okay, alphabetical order is how you list your ordered triple. And so here's another example of a unique solution. Okay, so now let's get into a non-unique solution system. Okay, so 1, 2, 3, number 4. This is going to be problem number 4. Okay, it's 2x plus y minus 3z equals 5. X plus 2y minus 4z equals 7. 6x plus 3y minus 9z equals 15. Okay, so here's our system. We have to solve, label it 1, 2, 3, and we're going to look, and I'm going to say to myself, I'm going to eliminate x because I have just x here. I could do the same with y. So really, if you choose eliminate x or eliminate y, those are the two most efficient variables to get rid of first. So I'll just eliminate x. And I want this equation twice. So I'll do 1 and 2. And then I'm going to eliminate x in 2 and 3. Okay, so that's going to be 2x plus y minus 3z equals 5. X plus 2y minus 4z equals 7. And I'm going to multiply the second equation here by negative 2. So I'm going to rewrite the first equation. 2x plus y minus 3z equals 5. Negative 2x minus 4y plus 8z equals negative 14. And now I'm going to add these together. X's are gone. That gives me negative 3y plus 5z equals negative 9. Now, I apologize for not going through this in the first 3, but what this is telling us right here, okay, is that these two planes, plane 1 and plane 2, are intersecting at this line. Okay, so you should see that in the document that two planes intersect and form their intersection is a line. This is the line at which these two planes intersect. okay? And so now what we're doing here when we eliminate x is actually seeing where's the intersection between these two planes. And then when we solve the system for the two variables, we're looking to see, okay, where do those two then intersect with this? Okay, so we want to get rid of x, so we have to multiply the first equation by -6. So I'm just going to write it right below. And so that's going to give us -6x minus 12y plus 24z equals -42. And so that is what we have to add together, those two equations. And so that gives us, this is gone, -9y, okay, plus 15z equals -27. Okay, so these two planes intersect at this line. So now what we're doing is we're making sure that these two lines intersect. Okay, and if they do, then we have a unique point here, if they intersect just once. Okay, so this is our system. Okay, I'm going to erase it. So this is what I have to solve. So I'm going to multiply the first equation by -3, and then that will get rid of y, okay? So I'm going through, right? Same thing we did in the first three problems. Okay, we got to our two variable system here. We saw, okay, 1 and 2 intersected, we got this. 2 and 3 intersected, we got this. So we take this, we get 0 equals 0. So what that means is these two lines are the exact same line. We just got 0 equals 0. That means, okay, that these two lines are the same. So that means we have infinitely many solutions. So any coordinate point y comma z that falls on this line is a solution. Okay, so we have infinitely many solutions here. So what this is saying is instead of the intersection point being a point, for this problem, since we got that it was a line and a line, and then it was the same line, okay, what this means is you have a line is actually your solution here. So you have infinitely many solutions because the line goes on forever. The two different types of solutions you could have for infinitely many is these could all be the same exact plane, and therefore the entire plane is the solution. So that's infinitely many solutions. And then when you get a line as the intersection, that's also infinitely many solutions. But just know, okay, when you get to your two variable system, if in the two variable system you produce 0 equals 0, or true, just a true statement, 3 equals 3, okay, that is when you know you 100% have infinitely many solutions as your answer. If you are in the stage of 1 and 3 and the pairing, and you got infinitely many, but then you got no solution, okay? No solution supersedes infinitely many, okay? And number 5. Number 5 will be the last problem. And then I will make a separate video for a word problem. Okay, so same thing, got a 3-variable system here, and we need to solve it. So, same steps. Okay, label 1, 2, 3, pick a letter to eliminate. I'm going to eliminate y because I see a negative y and a positive 4 and a positive 6, so I like that. So I'm going to eliminate y. So I'm going to put 1 and 2 together, and then I'm going to eliminate y with 1 and 3. So 1 and 2, 3x minus y minus z, I'm sorry, look at that, messed that one up, minus 2z equals 4, 6x plus 4y plus 8z equals 11. So I'm going to eliminate y, so looks like I need to multiply the first equation by 4. So I'll write that right below this equation here, that way everything is next to each other. And I won't have to rewrite this equation. I get minus, 12x, negative 4y, negative 8z equals 16. Add those together, and I get 18x, these cancel, equals 27. Ooh, so I have 18x equals 27. So I can see I'm going to be able to tell what x is. Okay, so it looks like 1 and 2, okay, intersect, and they intersect at the line x equals 27/18. Then for the second pairings, 3x minus y minus 2z equals 4. And 9x plus 6y minus 12z equals 23. And so I'm going to multiply the first equation. Remember, I have to get rid of y. So multiply the first equation by 6. And that puts us at 18x minus 6y minus 12z. Did I write that down right? 3x minus that, right? 18x minus 6y minus 12z equals 24. And we add this together. Oh, hold on one second. Let me make sure I wrote this down right. I'm looking for a mistake here. I need to see if I made any mistakes. 12x, 16, okay. So we've got 27x, add that up, the y's cancel, minus 24z equals 47. Okay. Okay, so I apologize because the textbook said that this was supposed to be a no solution problem, but they are incorrect because it looks like we are getting a solution. So what we'll do is we'll finish up this problem, and then I'm going to end this video, and then on the next video, not only will I put a word problem up there, I'll put a no solution problem. But it does look like we're getting an answer here, a unique answer. I was trying to do a no solution problem from the textbook, but They are incorrect. So here's our system. It's 18x equals 27. 27x minus 24z equals 47. Notice, I know what x is. I just have to get x by itself. Okay, divide both sides by 18 and you're going to get what x is. X is 27 over 18. That simplifies down. Both are divisible by 9. That's 3 over 2. So notice I said you could get fractional, right, points. We all know all real numbers exist, right? They also exist in 3 dimensions. So x can equal 3 halves. So now we'll solve for z. So 27 times 3 halves minus 24z equals 47. So now it's going to get a little rough here. Okay, we have to do 27 times 3 halves. So that's going to put us at 81 over 2 minus 24z equals 47. So now we have to subtract 81 halves from both sides. So 24z equals 47 over 1 minus 81 over 2. So now we need to write 47 over 1 as a fraction with a denominator of 2 so that we're keeping an equivalent value but making it look different so that we can perform subtraction. So that's going to be 94. So it's going to give us negative 24z equals 94 minus 81 puts us at 13. So this is 13 over 2. Okay, so now we're going to have to make sure our algebra, we feel comfortable doing this. We divide by negative 24. Okay, this is called a complex fraction again. Dividing by negative 24 is the same as multiplying by negative 1 over 24. And that's going to put us at negative 13 over 48. Ooh, rough. So that's what z is. Z is negative 13 over 48. Yeah, these numbers are getting a little rough to work with, but still we can do it. Okay, and the last letter that we need to solve for, so we have x equals 3 halves. We have z equals negative 13 over 48. So now we're going to solve for y. So we're going to go back to one of the original. I will use the first. So 3 times 3 halves minus y minus 2 times negative 13/48. Woo! This is the fraction test right here. Equals 4. So 3 times 3 halves, that's going to give us 9 halves, minus y, that's going to give us plus 26 over 48 equals 4. 26 over 48, I can simplify that down. I can divide it by 2, so that's going to give me 24. And 26 becomes 13. And so I have to do 9 halves plus 13 over 24. So 9 halves plus 13 over 24. So common denominator of 24. So I'm going to have to do 12 times 9. That's going to give me 108 over 24 is the same as 9 over 2 plus 13 over 24. So that's going to be 121 over 24 minus y equals 4. And so now we have negative y equals 4 minus 121 over 24. So we need a common denominator. Common denominator is going to be 24. So this will be 96 over 24 minus 121 over 24. And 96 minus 121 is negative 25. And then divide by negative 1, divide by negative 1. That's the same as saying y equals negative 25 over 4 times negative 1. And so we get 25 fourths. Oof. So our answer is 3/2, comma, 25/4, comma, -13/48. Okay, and so we get another unique solution, and in the next video I will do a no solution problem and a word problem.